Let's do a couple different types of division. We'll do long division and then we'll do synthetic division. So here's long division. And the first thing that you want to make sure when you do long division is that all the placeholders are filled. If not, we have to fill them in when we write the problem. So here I know that this is to the fourth, to the third, but then notice the squared term is missing. Everything else is there, so we're okay. And here we've got squared, the first, and then just a constant. So in our divisor, we're okay. So when I write this problem out, then I have to be conscious that that squared term was missing. And so when I write this out, I'm going to have to fill that spot by putting in 0x squared. And it's important that you do this. If you don't, you will end up getting the wrong answer by the time you're done. All right, so to divide, really the thing that we need to focus on is just this x squared. And then it kind of looks exactly like long division, where you talk about how many times does something go into the first number, and then you start dropping numbers down one at a time. Well, now instead of dropping numbers down, we're going to drop terms. So when I look here, it's how many times does x squared go into 2x to the fourth? Or in other words, what do I have to multiply x squared by to get 2x to the fourth? Well, I clearly need a 2. And then since I already have 2x's here, to get to x to the fourth, I just need 2 more. So that's going to be 2x squared. So I write 2x squared up at the top. And then what do we do in regular division? We just multiply back through. Now, if you're wondering why I'm writing the 2x squared over here is I like to keep these things lined up because then when I run out of space up at the top, I know that I'm done. And I don't have anything else to do but the remainder if there is one. So now I'm going to multiply through. 2x squared times x squared is 2x to the fourth. This first term better always be the same, otherwise you did something wrong. Minus 6x cubed minus 4x squared. And this is why you need that 0x squared, so that you have something to actually subtract when it comes time to do that. And then what do we do in long division usually? We subtract. So here I'm subtracting. And just like the systems, it's important to remember that you are subtracting everything. So this term cancels out. So 2 minus negative 6 becomes 8x cubed. And then 0 minus negative 4 becomes plus 4x squared, and then bring down the next term. And now start the process all over again. How many times does x squared go into 8x cubed? So that's plus 8x. Multiply back through. And then subtract. Again, the first two are the same, so that's perfect. 4 minus negative 24 is positive 28. And negative 10 minus negative 16 would be plus 6x. Bring down the minus 9, and this will be our last trip through because we know we're done. There's nothing else there. So that's going to be plus 28. And so we've got 28x squared minus 84x minus 56. Those go away, so we're left with 90x, and negative 9 minus negative or plus 56 would be plus 47. Now, since there's nothing left to go to at this point, this becomes the remainder. So then the way I would write the answer would be plus over. So you kind of make a fraction out of it, just like if you divided and got, for example, 5 1/8. So this is the full answer to that one problem. Now, synthetic division is a lot faster, and especially on a multiple choice test, there's certainly no reason not to use synthetic division unless you don't have the conditions for it. So here's one of the conditions for it, and you should be dividing by a linear binomial, which means that it should be x plus or minus something. So there should be no x squared terms. There should be only two terms in it, and it should be very simple to divide by, and that allows us to do synthetic division. Anything else, we're forced into the long division. The other thing to make sure of, just like last problem, is that all your places are filled. So we've got 4, 3, 2, but 1 is missing. Okay, you shouldn't have to worry about it on this end in synthetic division because there's only two things that have to be there, and if one is missing, then we're not really doing polynomial division to begin with. So to set up synthetic division, the first thing I'm going to do is I'm going to write these numbers, or just the coefficients, across in a row, and again I'm missing the single, or the x to the first term, so I'll fill that in with a 0, and make sure you include the signs. And then what we do is, to use as a divisor, we're going to use the second number in the binomial, but we're going to flip its sign. Okay, don't forget to flip its sign, otherwise that's going to mess everything up. Now, I'm not going to go into the why this all works here. You should have done that in class. If you want to see the whys again, then I'd be more than happy to show them to you at another point in time. But I'm just going to show you the how here. And so the first thing you do is, and you'll see it's much faster, is just whatever this first term is, just drop it right down to the bottom. So if it was a 5, I'd drop the 5 right down there, and that's my starting point. And then all we do is we just constantly multiply and add. You take the -1 times the 10, that's -10, add the add the two numbers left. So you can watch as this kind of goes along. 5 plus -10 is -5. -5 times -1 is 5. 4 plus 5 is 9. -1 times 9 is -9. 0 plus -9 is -9. And -9 times -1 is 9. -9 plus 9 is 0. And so this last column is always the remainder. And so in this case, we have no remainder at all. And so basically what we're going to do is, since we're dividing by x into x to the fourth, then it's just cutting the polynomial's degree down by 1. So this first term will always be 1 less than the first term in the original polynomial. So then my answer is going to be 10x cubed minus 5x squared plus 9x minus 9. And that's my synthetic division answer. And as you do enough of these, you can see that the math is just a matter of multiplying and adding, so synthetic division does become much faster than the mess that we just did in the problem before.